Hello.
Yes, ma'am, you're audible.
Okay. So I will share my screen.
Yes, ma'am.
So everyone is able to see my screen?
Yes, ma'am, it's visible.
Okay. Uh, I'm hearing an echo, so everyone can mute. So today I will be demonstrating OpenCV using Google Colab. So as she said, my name is Sanjana Maria Matthews. I'm a robotics engineer working in TCS Rapid Labs Trivandrum. So let's start with this session. So first we need to know what is computer vision. As you all know, computer vision is a field of computer science that if we have some medias like images or videos, we need to process it, analyze it, and understand them. And we should be able to get the data or processed information from them. So technically, the machine will be interpreting the media files and then analyzing them and will be handling them and will be through some algorithms, through some robust algorithms, will be generating some results. So that's the main purpose of computer vision. The tasks such as object detection, object tracking, etc. are some of the examples of computer vision. Computer vision is a wild area where we can explore, and it will be very beneficial. Even in the case of robotics, also, this is a major important part. So the machines will be seeing all the images as a series of pixels, each of the pixel having some variables. So this is the architecture of a computer vision. Uh, like us, like humans will be able to see a real world using their eyes. Similarly, in a computer vision, there will be camera to see the input, and our brain will be processing the input. Like we are able to see see a flower, we will be able to analyze it, and we will be able to know that that is a flower. Similarly, there should be a brain, there should be some intelligence to extract the relevant information from the input and then analyze it and then interpret it. The output will be maybe some processed images, or there will be the patterns recognized, or there will be the it will be the classified things. Like for example, if there is some mass classification algorithm, there will be some system and a camera attached to the system. The camera will be able to take the picture of a human being, and the particular image will be sent to the processor to analyze. Before that, we need to do some pre-processing for the images to get the features, to get the maximum features, and to analyze it in an effective way. So we will be doing some image processing and all. If it is a video, it will the video will be converted to frames, and we will do the pre-processing, and after that it will be sent to a deep learning network, and it will process, analyze information, and we will get the desired information. So that's the architecture of a computer vision. So this is how a machine sees an image. If a machine is getting a grayscale image as input, it will be seeing it as pixels. Each and every point in this image will be seen as pixels in that way, in this way. Like this is here, you can see this is a black color. So the machine will be interpreting it as a uh, different pixels, and for each pixels there will be some value. Since this is a grayscale image, it will be having values ranging from 0 to 255. 0 is less bright, that means it is black. So the pixels having 0 will be darker color, and the pixels having 255 will be white. Similarly, the pixel variation will be between this 0 to 255. So we can say that if the pixel intensity is 127, it will be gray. Similarly, for all the pixels, there will be a color. This is for grayscale image. If the image is binary, it will be like 0 for black image and black pixel and 1 for white pixel. If it is a color image, there will be RGB 3 channels, and we will be indicating each and every pixel coordinate as a combination of red, green and blue. You know that when we mix red, blue and green in to the most highest combination, we will get white. In that way, the machine will interpret color images. Okay. So this is how the machine will be able to see an image. This is how the machine will be interpreting an image. So while considering OpenCV is a computer vision library. We also we can see that this is like an array. This is like a 2D array. A grayscale image is like a 2D array. So if we want to make some modification, we need some array manipulation libraries, and we need things like that. So this is the input we are getting. From the pixel intensities, the computer algorithm will make the corresponding processing that it is required to do, and then if required, it is given to a network, convolutional neural network or anything like that, to analyze the information and to make decisions, etc. And as an output, we will get the required information. So computer vision algorithms, that we can use it for pattern recognition also. So computer process the image, label the object, and then find pattern in those objects. Like if the computer is seeing some flowers, if the computer is seeing some animals pictures, it will reprocess the information, and then it will collect the features. It will recognize the patterns from it, and according to the patterns, the convolutional neural network will be able to classify it into different categories. So, considering the evolution of computer vision, the first experiments with computer vision started in 1950, and at that time, the main problem was the capability of computation was less. Computation power was less comparing to nowadays. So there was a possibility of high error because of the less capability of computation, and also the data samples for analysis has to given manually. Nowadays, you know that the data is infinite. There is infinite amount of publicly available visual data and everything like that, and there are facilities to pair the algorithms, the artificial intelligence algorithms with the hardware, so that we can make a robot like things. The robot is a hardware with some artificial intelligence. So in that way, nowadays we have a infinite amount of data. On daily basis, we are also creating data. For example, if we are searching on shopping site, we are searching like since I am an electronics engineer, maybe I will be searching for electronic components. So the algorithm will be able to identify there, okay, this customer needs these types of product, and according to that, they will collect the information from us, and they will tune their algorithms according to that, and they will suggest the related things that I need. Similarly, nowadays, because of the availability of infinite amount of publicly available visual data, the evolution is very high. Also, the influence of deep learning helped in a revolution in computer vision. We have neural networks to extract patterns from the data. Uh, the data that we are getting as input values, that will be a raw data. It will pass through the neurons, and according to the patterns recognized features, extract, etc. In the output layer, there will be some prediction. If it is classifying a cat and dog, the raw information will be the pictures of the cats, pictures of the dogs. So in the neural network, it will identify the features, and according to that decision will be taken, and in the output layer, the test image will be predicted. The label will be predicted, means if it is a cat, the label cat will be predicted, and there will be some accuracy for prediction. So this is deep learning, and input is coming. The deep learning technologies will help us to extract feature, classify accordingly, and then give a output. So there are a wide range of applications for computer vision: content organization, facial recognition, self-driving cars, health, agriculture, etc. Also for training, also if there are things like virtual reality for if an employee needs to be trained in a sea in ships, we can provide virtual reality so that they will be able to trade in a virtual environment rather than going to the sea. Similar kind of things are some of the applications of computer vision. So we think that the huge amount of data that we create daily is a curse, but it is actually a benefit or a boon, so that the different machines can learn and understand, and they can provide services. They can provide better services to us. Okay. So next we will be dealing with image processing. Image processing is performing some operation to an image, and thus we can enhance the image, or we can enhance the features of the image. So we expect the output of the image processing as an image or the characteristics recognized from the image. So the input will be image and output will be image or characteristics. And there are different types of images. As I said, there are images like binary images, that are black and white images, then grayscale images, and then color images. So you can see here, this is a binary image. This is a black and white image. So the machine will be seeing a black and white image like this. All the white pixels will be identified as 1, and all the black pixels will be identified as 0. So you can see that each pixel is having some value. This is a 2D matrix. It have a height and width of it have a dimension of 35 by 35. So you can see that each and every pixel is a number. So this is a binary image. This is how a machine will see a binary image. Similarly, the machine will be able to identify a grayscale image like this. As I already said, the intensity values will range from 0 to 255. If it is 10, maybe it is darker, and if it is 200, it will be a light pixel. In that way, each of the each of the pixel will be having some intensity value like this. Similarly, for a color image, it will be represented in RGB. So you can see that a color image will be like this, and each cell will be a pixel. Each pixel will be having a RGB coordinates. Like this will be the intensity value for blue, and this will be the intensity value for green, and this will be the intensity value for red, BGR, in that way. So you can see that if the coordinate is 0, 0 to 55, the particular pixel will be red. So if this is, if there is a point here which is red, the particular coordinate will be 0, 0 to 55. For can you guess like what will be the coordinate for green? It will be BGR. For green, it will be having a high value. For red, it will be having a 0 value. For green, for BGR. For red, it will be having 0 value. Blue, it will be having 0 value. And for green, it will be having 255. So yellow is a color which is a combination of red and green. So it will be like B. Blue will be 0, red will be 255, and green will be 255. That way, there are different colors in the BGR color space. So for each color, there will be some value like that. You can see there will be a matrix for red, there will be a matrix for green, there will be a matrix for blue. For this is a three-dimensional matrix. So in binary, it is a 2D matrix having 0 and 1. In grayscale, it is a 2D matrix having pixel intensities ranging from 0 to 255. But in color image, it is a 3D array, a 3D matrix. It will be having a combination of red, green, and blue intensity values. So each of the pixel intensities will range from 0 to 255. If it is a red color, this will be 255, green will be 0, blue will be 0. If all are 255, it will be white. So this is how the machine sees the machine will show a image. So for each of the points, there will be a corresponding pixel coordinate. That will be there will be some value for R, G, and B. So another important concept you need to know before going to the OpenCV is if this is the original image, we need to process it, and if we want to sharpen it, what sharpening means is we want to find out the edges. Like this is a more blur image, we need to find out the edges and make the pixel variation more sharp. So by applying some filter, we will be able to make this image more sharp. So after there are a different kind of sharpening techniques. If we are checking the different sharpening filters and different techniques, we will be able to see a different set of things. And this is how an the image will be after sharpening. So similarly, uh, smoothing means blurring. So if we don't want the variation like this, if we don't want the edges like this, for example, if we have a if we have some dot in a, if we have some noise in a image, by blurring maybe we will be able to denoise the image by it will be taking, if there are different technologies, one of the method is it will be taking average of the neighboring pixels. So if there is a dot here, by when the filter is taking the average of the neighboring intensities, and when it is replacing the particular intensity, then the particular dot will be removed. Similarly, the noise will be removed from the image if we are using smoothing or blurring according to our requirement, not for all cases. So this is the output after sharpening, and this will be the output after smoothing. Also, if we are increasing the order of the filter, corresponding change will be there for smoothing and sharpening. So this is how it will occur. There will be a matrix. This is a one of the techniques for smoothing. Smoothing means blurring. So there will be a filter. So I am considering an averaging filter. So this is having one. This is a 2D matrix having one 3 by 3 2D matrix. So the 1 by 9 is multiplied to it, so that when we move the filter through the image like this, through all pixels like this, when we move the filter through all the pixels in the image like this, at each point it will be computing, it will be convolving with this, and after that will for example, if we have some pixel intensities here, 255, 100, 90. Similarly, we will be having some pixel intensities. All this matrix value is 1 by 9. So each element will be multiplied, and then we'll be taking the sum of the pixels. We will, and since it is 1 by 9, we will get an average pixel. considering the neighborhood of a pixel. So when we move the filter from one pixel to another, at each point we will be getting an average value considering the neighborhood value. So it will be replaced. In that way, if there is a dot here, if just a dot, that is a noise. If it is a noise, that considering the neighborhood pixels, since other pixel intensities are light, but there is one noise by there is one dot here, considering the neighboring pixels, it will take an average. So the new pixel will be may not be having that black color. Maybe it will not, may not be much in the, it may not be much dark. So in that way, we will be able to denoise by smoothing. Also, you can see here, to place the filter at this point, we need to layer pad, like by adding zeros here, we will be able to use the filter at these type of pixels, like the edges. Okay, then we want to know also thresholding concept. So you can see this is a grayscale image having pixel intensities varying from 0 to 255. So this will be probably 0 and this will be probably some 200, like since it is a light value. Similarly, all the points here has some pixel value. We need to convert it into binary value. So we have to set a threshold. For that, we have to this is a histogram, and there's a concept called histogram. Like in this x-axis, we'll be having the pixel intensities ranging from 0 to 255, and in the y-axis, it is having frequencies, like the occurrence of each pixel. Since the black color is more in this pixel, there is a huge huge curve at this intensity. So we are setting a threshold. Probably it will be 90, so that less than 90 values, we are making it 1, and higher than 90 value, we are making it 0. By applying threshold, we are converting it into binary value in this way. Here we are setting a threshold which is 90. So considering the threshold, less than the particular value will be 0, will be 1, that is white, and greater than the particular value will be black, that is 0. Okay. So now hope you understand some of the concept of image processing and computer vision. So next is OpenCV. OpenCV is an open source library for computer vision, machine learning, and image processing. It will be able to support Python, CPP, and Java. And I will be demonstrating using Python in Google Colab. So the OpenCV will be helpful in processing images, videos, etc. And using OpenCV, we will be able to identify objects, faces, handwriting of human, etc. So, as I already mentioned, we have the pixel intensities as a matrix. This is a 2D matrix. So the problem is, if we need to manipulate this thing, if we manipulate a matrix, we need a library which is useful for array manipulations and all. So we will be commonly using a library called NumPy, which is a optimized library for numerical application. And integration of NumPy with OpenCV gives a very good results. So some of the applications of OpenCV are face recognition, automated inspection and surveillance, count, anomaly detection, etc. It is very much useful in medical image analysis also. To see the anomalies and all. Anomalies is like a defect in image. Like if it is a X-ray, if there is some anomaly or if there is a defect, by making use of a computer vision algorithm, we will be able to detect the anomaly from the image. Okay, so these are the steps. First, if we want to process a image, first we want to import the image, and then second thing we want to analyze and manipulate the image, and then we will do some processing on that, and there will be some output. So the computer reads all images as range of values from 0 to 255, and for a color image, it will be having three primary channels, red, green, and blue, and each of the pixel coordinate will be a combination of B, G, R, blue, green, and red. So NumPy, as I already said, it is a array manipulation library. It is a Python library used for working with arrays, and it has some functions for working in domain of linear algebra, Fourier transform, etc. And it provides a high performance multidimensional array object, and it has tools for working with this array. So we can make use of NumPy to initialize some image, like if we want a black image initially, and we will be doing processing on top of that. Using NumPy, we will be able to make an array having full zeros. Similarly, we can make an array having full one. In that way, we can initialize arrays, and that arrays will represent an image. And also, using NumPy, we will be able to manipulate and modify the pixels. Also, using NumPy, we can define the filters. And I said about smoothing, blurring technique. There were filters which is passing through each and every pixel coordinates through the image. So to define that filter also, we will be needing NumPy library. So it is useful for array creation. Using np.zeros function, we will be able to create a array having full zeros. Using np.ones function, we will be able to create an array having full ones. Similarly, we can slice if we require a part of the array. We can actually access the only that area using slicing. And also, we will be able to integer array index and get the element or modify the element. And there are also different kind of operations, and we can make use of that for our image processing techniques. np.add, np.subtract, etc. So let's try everything in OpenCV. So first we need to familiarize with Google Colab, and then we need to install OpenCV. Then we need to do a set of things. So first we need to go to the Google Colab, and we are planning to demonstrate the OpenCV functions and all in Google Colab. So copy this link. I will ping it in chat box. Hope you got the link. Once you are able to access the link, if you are not signed in Google, you need to sign in first. Once you sign in, you will get a window like this. You can select new notebook here. Or by clicking on file, we will be able to create a new notebook. So now we have a notebook. So you can try parallelly also if you have an additional asset. So next thing is we need to change the name of this Python notebook. We can give like OpenCV. Okay, I gave a name. So we have things like this is a code cell. If we want to add more code cells by keeping the mouse pointer here, we will get this thing, the code and text buttons. And once we reach here, click on the code to get new code cell. If we want to give a description kind of things, this will be useful. By clicking on text, we will be able to type something here. So I have typed like this. Okay. So this is a code cell. We can type our code here. The first thing is we need to install OpenCV library. So to install, just give exclamation mark and then type pip install OpenCV contrib Python. Also, we need to install NumPy. So pip install NumPy. As I have already said, NumPy is a library for array, and OpenCV contrib Python. By installing it, we will be able to use the OpenCV function, and also we will be able to get the libraries by the contribution from the community. So by clicking on the play button here, we will be able to run the code cell. Okay, so once we get a tick here, we can see that. Are you able to see my screen? Do I need to enlarge? Okay. Hope you are able to see my screen now. Okay. Once we get a tick here, we will be able to know that this is successfully executed. So next thing is we are going to read an image. So we need to add the image here. Click here. We will get this window. Right click, then upload, and then we have a set of images. I'm taking this one and open. Then click OK. It is loading. So now we have an image here. Double click on that to see. Okay, so now we have an image. So we are trying to read image, and we are going to assign it into a variable. For that, first we need to import OpenCV library. So the type import CV2 and give us CV. Import CV to a CV. So by typing CV dot the function name, we will be able to access different functions for OpenCV. And we are assigning it in a variable img. img equal to CV dot imread. We can press on Control and space for suggestions. Okay, so inside imread, we will be able to give the path required. So to give the path, we can in a single course we can give the location. So the particular file is lying here, so we can give the name of the file directly. If there is a folder, we can give the path like that. Pug.jpg is the name of the file. Okay, so if we are pressing the play button, we can see that the code is executed. Now the image read from this file is there in img image, but we need to see the image. For that, we can use this thing cv underscore im show of img, but we need to import library for this. In our PC, if we are executing it in Python IDE in our PC, the command will be like cv2 dot im show. uh, that will be already there, since in system the image will be coming as window, but here we need to use an extra library to make use of this function. Import cv2 underscore im show from google.colab.patches. So give this line. So now we have cv2 underscore im show, and by making use of this, passing the image that we need to show here, we will be able to display it here. So you can see that the image is here. So we can type here also, but if we are typing here, we need to re-execute these things. We don't need to do that. So we are typing the next line of code here. So we need to get dimensions of this image. So we need the width of this image. To get the width of this image, assign a variable width equal to image. Variable is img. You can see here the variable is img, image dot shape of 1. So this is the width and this is the height. So shape of 0 will be the height, shape of 1 will be the width. So width equal to img dot shape of 1. Similarly, what will be the height? Height will be img dot shape of 0. Okay. We also need to get the dimension of this image. So we are assigning another parameter, dimension equal to width comma height. If we want to display this, we can print dimension. So by playing this code cell, we will be able to see the dimension. 1920 is the width of the image, and 1080 is the height of the image. Okay. Next, we can extract the RGB of a pixel coordinate. Like for this, if we want to extract a particular pixel coordinate, maybe if we are extracting this pixel coordinate, it will be a coordinate representing black. Like it will be in a BGR format, blue, green, and red. It will be in that format. But if we are extracting the pixel coordinate of this thing at this point, we will be getting the corresponding color coordinate representing black. So next we are trying to get the BGR of a point. So B comma G comma R equal to img of the x and y location. So we get the R value. R will be the 0 to 255. There will be 0 to 255 pixel intensities for R. There will be 0 to 255 pixel intensities for green. And similarly, there will be 0 to 255 pixel intensities for blue also. For the 100 in x and 100 in y coordinate, we have the RGB coordinates like this. As I have said, in this manner. If it was a red point, the R will be 250, R will be 255, uh, green and blue will be 0. Yeah, so we got the RGB values of a pixel with X and Y 100. So next we are extracting the region of interest. If we want to add some text here, we can type here bold extracting ROI. Okay, select them. Okay. So next we are going to access a particular region of interest. If we want to access a particular region of interest, we can give the coordinates like from x, the this is the x and this is the y in an image. So we have to provide the start and end values for the x axis and the start and end for the y axis. In that way, we will be able to extract a region of interest. So we are assigning the region of interest in a variable ROI, img of in the x we are giving 500 to 1080. We have already saw that this is a width and this is a height. So height is ranging from 0 to 1080 and width is ranging from 0 to 1920. So we are planning to extract the region of interest in x-axis 500 to 1080. 500 will be here, 500 to 1080, and in y-axis, we have to give 500 to 1920. It will be 500 to 1920. So just check cv2 underscore im show, which is the function in Google Colab to display the image. ROI is the region of interest. So as we expected, we got this region. 500, this ranging from 500 to 1080. That will be, x will be from 500 to 1080 and y will be from 500 to 1920. So the region of interest is like this. Next, we need to resize an image. For that, using like if this is of scale 1, using we can resize using a parameter also. Like if we are giving a scale value 0.75, the resized image will be 75 percentage, will be having 75 percentage dimensions of the original image. In that way also we will be able to resize. So now we have the image in the image variable. We have the image in the image variable. Considering that, we are deciding a resize height. Resize height is equal to integer value of img dot shape. That is like if we want to get the height, this and we are going to reduce the image by half. This is the width actually. Okay. Then we need height. So integer value of inside this, we need to reduce the height dimension by half. So it is in img dot shape of 0 is the height of the image, that is this value, and we need to reduce it by half. For that we are multiplying by 0.5, and then we need to uh, convert it into integer value. For that we are using this function. That particular value is stored in resize width and resize height. So we have a resize dimension also. Dimension is the original dimension of the image. Now we want a resize, we want the dimension of the resized image. So like this. So we have dimension. So we are going to store the resized image in this variable, resized image. We have function for resize in OpenCV. We have already imported the OpenCV, import CV to a CV. So to call a OpenCV function, we can call by accessing CV dot the function name. So now we are accessing by CV dot resize of. First we have to give, here we can see what all the parameters it is expecting. So first we have to give the image variable. IMG is the image variable. We have already seen that. Here we are reading the image and storing to IMG. So IMG is the variable read. And next we need to provide the dimension size. So copy the variable and paste it here. Next we need to give the interpolation. I will explain interpolation later. If we are stringing the image, we can use cv dot inter area. If we are zooming an image, we have to use some other interpolation parameters. Inter area. Okay, so next we need to display the image also. cv2 underscore im show of resize image. So this is the original image. This is the resized image. If we want to see here itself, before this we can provide the original image. If we need to stop it in between, we can click on the stop button. Okay, so this is the original image. This is the resized image. If we are not giving same scale for the width and height, the image will be like this. So I have scale down height 2.1 and scale on width 2.5. So in the new dimension, the image will be like this. Since I have given same uh, same scale in the earlier case, I have preserved the height and width ratio. Okay, so this is how we resize image. If we are, if we, in some cases, we need to resize the image first. For example, if we have to add two images, the particular two images should be having same size, so we can resize. Also, for computation efficiency and all, we can resize. For different application, we need to resize. In some cases, the image will be outside the monitor, so in that case also we need to resize. For according to our application, in most of the cases we need to resize the image first. Next is rotating the image. Add text here and then type rotating image. Now also we have the image in the variable img. For rotating, we need a rotation matrix and we also need an angle to rotate. If we are giving a positive angle, it will rotate anti-clockwise, and if we are giving a negative angle, the image will rotate clockwise. So first we are giving the rotate point. The point it should rotate. The with respect to that point, this will rotate. So rotate point equal to I am considering the rotate point as the center of this image. So I am considering here for getting the center coordinate, we can access the shape and divide by 2, we will be able to get the center pixel coordinate. So img dot shape of 1, 2, comma img dot shape of 0. So we got a rotation point. Next, we need to create a rotation matrix. With using the matrix, we will be rotating the image. To get a rotation matrix with respect to a point and with a particular angle, we have a function called get rotation matrix truly. To get the function CV, we have imported CV to as CV. So by accessing the particular object of the library, a dot, and then using the function get rotation matrix. This is the function. To get suggestions, control and then space. Press on control and then space. Okay, this is the function to get the rotation matrix. If we are passing the point to rotate, the point at with respect to which the image should be rotated, and then the angle, okay, and then the scale. Okay, so this is the point. And next is the angle. So yeah, we want to rotate the picture 30 degree to counterclockwise. So we are giving 30. And we have to give the scaling factor. Scaling factor is 1 itself. So rotated image is stored in rotated variable. And we have a function called warp affine, which do the affine transformation of an image. So CV dot warp. Okay, control press control and space to get the suggestions. So this is the function. Okay, in that we will be able to pass the variables. First pass the image and then pass the rotation matrix. This is the rotation matrix variable. And next we need to pass the dimension. Since we are giving img as the image, so this will be the image. Dimension of this image we have already have it in this variable. So in that, or we can mention it as a tuple here. Okay. So let's display the image CV2 underscore show rotated. I am show, sorry. I am show. So the image is rotated. We can also rotate the rotated image again. Okay, for that taking this so that we don't need to write it again and add a code cell here. Next we can rotate counterclockwise. This now we have rotated anti-clockwise. Next we can rotate counterclockwise 60 degree. Okay, and we are passing the rotated as the input to rotate. So this is the thing. And also we need to display the image. Okay. So it is rotated 60 degree. It rotated 60 degree of this image with respect to a point at the center. Since we have given the rotation point like this, and then the image will be like this. Okay, so we have done the rotation of an image. Next, we can do translation of an image. Okay. For that, we need a translation matrix. To define a translation matrix, we need a library uh, for array manipulations. For that, we are importing numpy as np. To follow the conventional approach, we can cut this and paste in the top library side also. Now, just for understanding, I am keeping it here. And then we have to define the x and y coordinates it's need to translate. So, defining x as 300 and defining y as 300. Okay, then trans matrix equal to nb dot. We want a plot 32 data type array having two rows of the both will be list 1, 0, and then x. And next one is 0, 1, and y. So this will make a translation matrix. So the x, we can define the x here, we can define the y here. So this will make a translation matrix by making use of the warp affine function, which is a function that transforms the source image using the rotation matrix. We will be able to calculate the new xy coordinate of the image and transform it. And okay, so now we have a matrix, and next we need to pass the rotation matrix and the image to the warp affine function. Okay, we can give the variable as trans cv dot warp warp affine of img, which is the image, and trans map. And next is the dimension that we already have. Okay, so let's cv2 underscore I am show to display the particular image. Okay, okay, we need a okay, so the image is translated. Are you able to hear?
Yes, we can hear you.
Okay. Okay, so the image is translated. We have given x coordinate as 300 and y as 300. So it will shift the image. This is the x direction and this is the y direction. In every case, this like in normal case in graphs and all, this will be the x and this will be the y. But in the case of image, this will be x and this will be y. So giving x as 300, y is 300, and making the translation metrics and passing it into warp-affine. So by making use of the warp-affine function, we have translated the image to 300 in X and 300 in Y. You can try changing it. This is Y and this is X. Next, we need to, this is like, if we are giving positive value in X and Y, it will be going downward and rightward. Similarly, if we are giving negative values for both, the image will be going up and left. You can try out different things, giving X as 300 and Y as minus 900 degree. So X it is translated 300 and Y it is translated 900 in the other direction, top direction. Similarly, giving this as negative and giving this as 900. Okay. So 900 it is it have moved in x-axis it have moved minus 300 and y-axis it have moved 900. Next is we need to draw a rectangle on an image. So we have an image. So we are going to draw an rectangle on an image. Rectangle equal to CV dot rectangle. This is the function to draw a rectangle on an image. We will be able to pass the image, the top left corner coordinate and bottom right corner coordinate. We have a box. So the first point will be the top left corner coordinate and the last point of the box will be the bottom right corner coordinate. Bottom right corner coordinate. So also we have to define the color at which the line should be drawn. Also, we have to specify the width of the line. Okay, CV dot rectangle. Passing the image that we need to draw the rectangle, IMG of 0, 0. So this is the first coordinate of the box and we need to define the second coordinate of the box. This is the second means bottom right coordinate. Okay, next we need to define a color. So as I have said, color is defined as BGR. So we need a blue color. So B is given as 255, G as 0 and R as 0. And we are giving the thickness as 2. So now we have the image in rectangle. We need to display the image here. So the as we have mentioned, it is blue line of thickness 2 and the first coordinate, which is the top left corner coordinate, it is having 0, 0. So this is the thing, and the second coordinate is 200 in x and 200 in y. So let's try changing it to 600. So we got another line on top of this. Let's create this image again to avoid the unnecessary line. Okay, so we have given xs 200 and ys 600. So uh, this is the 200 600 coordinate. So the box is drawn like this. If we want to give a red, this is p g r. So if we want to give it as a red line, we can give like this. Okay, you can see that this is a red line. Similarly, we are giving values for both green and red. So it will be the color combination of mixing green and red. That is yellow. Similarly, if we are giving 255, B, G, R, all 255, it will be white. So we can also change this value also. 100. Starting value. Excuse me. 100. So this is a point 100, 100, 100 from here, 100 from here. And this is the point 200, 600. 200 from here and 600 from here. And next we need to display a text on an image. For that, if let's before that, let's try displaying the image here. So the image is also modified. So if we don't want like this, we can copy it into different image and then use it. For that, if we are running this again, uh, not that, we can before adding rectangle, we can copy the image to some other variable. Output equal to amg dot copy. So a copy of the image is there in output. We can pass output to rectangle so that the original image will not be modified. Okay. So if we are running this, original image is not modified. The rectangle is added to the image stored in variable output. Okay. So next we are going to display text on the image. Okay, I will explain it. Okay, in that case also we can define this again since there is a rectangle in the previous image. So I am copying the image to output variable, and then we need to define it into a variable. The text will be added to the image. We need to say the particular thing to a variable. We have a function for OpenCV for this. For that, CV dot then put text, and then in that pass the variable output, which is the image, and then we need to give the text that we need to add. OpenCV workshop. Okay. Next is we need to add the coordinates that it should be displayed. I'm giving 1000 into 55. And next I have to give the font face, like the face of the font, Arial, in that way. CV dot font underscore. By control and by pressing on control and space, we'll be able to see the suggestions. In that there are different things. I am using this one. Okay, then next is the font size 1.0. You can see it here. Image, text, or origin. The text need to display in the image. The font face, that is here, and the font scale. One is the size of the font, size of the text. And next is the color. So let's give like this: 255, 255, 0. B and G values are 255. So the combination color of blue and green will be displayed for the text. And the last thing is the line width. Okay. Then next we can, this is also an image. So we can display it using CV2 underscore I will show. So cyan is the color when B and G are 255. So this is the font, and this is the size of the text. Let's try changing. Okay, here now it is at 1255. We can change the coordinate. Okay, so we have added a text. For example, if we are doing an artificial intelligence, for example, if we want to recognize the face of a person, maybe the algorithm may be recognizing the face of the person, and then we may be having the recognized name in a variable. So, in a variable detected text equal to detected name of the person. So by making use of cv.putText, we will be able to put text, and also if the face is detected using some algorithm, by making use of cv.rectangle, we will be the ROI will be detected using face detection, any face detection algorithm. If we are making use of cv.rectangle, and by providing the pixel coordinates of the ROI and the color needed and the thickness needed, we will be able to mark the face in the image. Similarly, if we want to mark the text on top of that, also by taking the center coordinate of ROI, we will be able to place text, and we can give the colors, we can give the font face, we can give the text. In here, maybe the face of the detected person will be there. That is the significance of all the CV functions, like OpenCV functions that I have demonstrated today. Okay, so this is how we display text on an image by making use of cv.put text function. We will be we will be adding the text to the image by making use of cv.rectangular. We will be adding the rectangle to the image, and by making use of warp affine, we are making affine transformation. So the other features will not be affected. Only we we can translate or rotate it. The other pixel coordinates, other relations will be there. It will, the particular transformation will not affect any other things. So that the image will be retained as retained like that, but it will be rotated or translated. And also for generating the rotation metrics, we can make use of cv dot get rotation metrics 2D, and cv dot resize function is there to resize the image to a particular dimension. Okay. So next we can try out some arithmetic operations on the image. So first I will show it as an error so that you will be able to understand. We have an image in IMG and we have another image IMG2, IMG1. This is IMG1, this is IMG2. So to upload another image, right click here, upload, and then take this image and then take open. Wait for this to upload. So it is uploaded. Double clicking that, we will be able to see the image here. So instead of this, we need to read read image read this image lenn.png. Let's run. So we have image in img1 and img2. We can try adding both images by giving some weight so that both images will be merged. Sum image. For summing up two images, we can use the function cv dot add weighted. This is a function to summing up two images. We can give the image, first image, and then we can give the weight of the first input image. So that is 0.5 in this case. And then the name of the second image. And then give the weight of the second image. Next is a gamma value. That's a measurement of light. Okay, so now we have it in some image and we need to display it using cv2 underscore im show. But probably I will get an error now. Error says is like the two images have two different dimensions. So using this, we cannot add both of the images. So we need to resize it into particular dimension so that we'll be able to add the image. To resize, we have cv.resize function. Resized image equal to cv.resize function. In cv.resize function, we can pass the image 1 and then we can fix a dimension for the image. 400 by 400 may be fine. And then interpolation. If we are resizing to a lower value, cv dot inter area will be fine. Okay, so we have resized the first image and to a 40 by 40 dimension and it is stored in resize image 1. And we have resized this to and stored in this. Okay, resized image 1 here. I'm giving resized image to here, then trying to run this. So you can see that both of the images are merged. The image Lenna is merged with the image Pug. Similarly, we can also try out subtraction also. For subtraction, we have a function cv.subtract. And I will show edge detection. For edge detection, we have function we are storing the edge detected variable to edges. We have function cv.canny. Can is a canny edge filter, and in that we can pass the image, and we can give a lower threshold value and a higher threshold value to detect the edges. you can see that the edges of this is detected. This is how like there will be some variation, some sharp variation of pixel intensities when we are considering the boundaries of the object. So there are some techniques to identify the sharp pixel variation, and by identifying that, edges will be detected. So edges are detected like this. And next, we can try blurring an image. For blurring an image, there are different techniques: Gaussian blur, median blur, etc. Here I am using Gaussian blur. 7.7 is the kernel size. So trying now this. Okay, this I will display the image also so that we can identify the difference. Show image. And this is the original image. This is the blurred image. There is, you can see the image is blurred. The edges are more smooth in this. And we are giving another kernel. This is a 7x7 filter. I hope what this is what a filter is. The thing that is passing through the pixel coordinates for transforming the pixel coordinates. So here I have given a 7x7 kernel. If I am using a 3x3 kernel, let's see what will happen. This is a sharp image. This is a blur image. This is a sharp image. This is more blurred image. When I have increased the kernel size, it is more blurred. So we can try, if necessary, we can try out using the Lena image also. This is hello. Okay, this is the original image. This is the image when we applied a 3x3 kernel for Gaussian blurring. So this is a Gaussian blurring of 7x7 kernel. So blurring increased. Okay. Next, okay, I will conclude with this. Okay, then last one is what if for I have demonstrated how we can modify images, but what if we are modifying a video? Like what, how to access a video, or how to improve the quality of a video, or how to modify a video. So in that case, we need to assign it into a variable, and using cv dot video capture, we can take a video. Here we can, in this example, I am giving a uh, video here. Or if it was a Python environment, by giving 0, we will be able to access the camera live feed. or if we are giving 1, 2, if there are additional cameras, we will be able to access 1, 2. Uh, in Collab, if we need to access camera, we have few more steps. But in Python, if you are downloading the script as Python, and then if you are running it in Python IDE, by making 0 here, you will be able to access the camera visuals. So here I am giving the location for desktop.mp4. And then we have the video here, and then we need to get it as frames. So success is equal to with cap, which is the object, dot read. So we have to access all the frames that giving it in loop, where check success boolean, and then we need to display the frames. So we are uh, displaying the image frame. So we can see here all the frames in the video is displayed here. So for example, if we need to improve the resolution of this image, uh, inside this loop, we have individual frames. We can make modifications to the individual frame so that at last we will be able to uh, save all the frames to a particular location, and then we can make the frames again to a video and thus modify a video. For example, if we need to do face detection algorithm, image will be captured. Video cap equal to cv dot video capture of 0 if it is in a Python ID for like capturing from video feed 0, and then inside a loop access all the individual frames so that and then apply face detection to individual frames. If we need to skip the frames, we can do it by some skipping conditions and all. Inside the while loop, it will access each and every frame and will try to detect face from it. Okay, so this is how they access a video. So that's the end of the session. Once we complete, like if it was a continuous code, uh, once we complete coding, we can download it as Python file. There's an option here. There will be minute adjustments to make it compatible with the Python environment in the system. Like the things like CV2 IM show will not be there in if we are running it in our system. We don't need this library. Instead of this, we have to give a cv2.im show of window name, comma, the image. It's similar, that kind of minute changes will be there. But once we are able to simulate once we are able to do everything in Google Colab, the main advantage is like we will be able to see the output of each and every step here itself. And once everything is fine and good, we will be able to download it as we can download it as a Google Colab notebook file or as a Python file. If we are downloading as Python file, by providing the corresponding changes, we will be able to run the code that is already tested here, and we will be able to make use of the Python script for our applications. So that's the end of the session. Thank you. Any questions?